A blissful evening to you, young learners of mathematics. This evening we shall be exploring partial. We shall be exploring partial fraction. We shall be exploring partial. In our previous class, we talked about direct variation. We have talked about inverse of indirect variation, and we have also talked about partial variation. We have also talked about joint variation. So this evening we are going to be talking about partial variation. What do you mean by partial variation? Now, imagine you are a fashion designer. You sew clothes for people. Let's say you want to make a skirt and blouse for customers. You know that if you want to sew skirt and blouse, let's say your fee is 5,000 naira. That one is the basic, that is non-negotiable. However, that skirt and blouse can vary depending on the customer's choice. For example, customer A can say, okay, when you finish sewing my skirt and blouse, I want you to put corset. I want you to put embroidery. I want you to put tenko and stuff like that. You know that the 5,000 naira you collect for sewing, that one is fixed. That's the constant part of it. Why other jara that is associated with it, those ones are the variable are the ones that vary. They are the partially variable variables. So when we talk about partial variation, it's mostly, let's say the cost of the clothes now. You normally charge 5,000. That one is a constant part. That's the constant part. Plus, if the customer now wants, all those things I've mentioned, maybe embroidery and want lace pads to be added, those ones are the ones that vary. Those ones, maybe you normally charge 500 naira, 500 multiplied by whatever that the person demands from. So this is the partially constant part, and this is the partially varies part. So most partial variation questions, they normally follow a particular order. C equals A plus X, something like this. So this can be the cost of the clothes, and this can be maybe this can be the cost of the clothes, and this one can be depending can be a factor depending on choice of design. Am I making sense? If the design is sophisticated, the money will increase. If the design is not sophisticated, the money will look the same. So basically, a partial variation question always follows this format, something like this. See, don't forget that previously we have said if it is direct variation, this is the symbol for direct variation. If it is inverse variation, we have something like this. If it is joint variation, we have more than two variables. It can be a joint and it can be a partial one. So, and now, if it is partial variation, it normally follows a pattern, something like a fixed price and a variable, a price that varies. Okay, so having understood that, let us take a question that will show us what we are talking about under partial variation. Okay, so let us see this example. I want you to listen carefully. Okay, x is partly constant. X is partly constant and partly varies. And partly varies with y. Okay, when y equals 30, sorry, when y equals to x is 30, and when y equals 6, x is 15. X is 50. Okay, so X is 50. Now let's answer the question that follows. The question says find the relationship. I've told you in the class that this relationship, they can mention it as formula or equation. Find the relationship between X and Y. And next question says find X when Y is 3. Okay, so let's dive into the equation right away. Now let us interpret it. X is partly constant and partly varies with Y. That's the very first thing you will interpret. So X is partly constant. X is partly constant. There's a partly constant part and partly varies with Y. So this is what you are going to have. Now, the very first set of data is for you to get the values of your constant. Note that under partial variation, we have two constants, unlike direct, indirect, and time variation, where we have just one constant. So for partial variation, there are two constants. Now let us insert the value. When y is 2, x is 30. So x equals 30, a that I don't know, plus b into bracket y, b into bracket 2. So what do? We open, so we have our 30 equals a plus b into bracket 2 means to be called that equation 1. Are we together? Okay, call that equation 1. Call that equation 1. Okay, so let's call that equation 1. Okay, so let's call that equation 1. Okay, so let's go ahead to interpret the second one. Okay, so now let's go back to the question. When y is 6, x is 4, x is 15. So I'll go back to my relationship. X equals a plus by. When y is 6, x is 50. So 50 equals a plus b into bracket. Y is 1, 6. So 50 equals a plus, that's 6b. I call that equation 2. Don't forget that we have two constants there. So when we bring them together, we are going to when we bring them together, we are going to find the values of the two constants. So let us put them together. What do we have? The first equation says 30 equals a plus 2, a plus 2b, while the second equation says 50 equals a plus 6b. Okay, so there is something I'm going to do. I'm going to use elimination. I will get rid of a variable to get one variable. Then when I'm done, so this is equation one, this is equation two. So I can say equation one, equation two minus equation one. I'll take away equation one from equation two. So what do I have? That will be 50 minus 30, that will give me 28 equals a minus a, that vanishes. 6a minus 2b, that gives me 4b. And this is turned to a simple equation that we can solve by saying divide both sides by divide both sides by divide both sides by 4. I have 20 over 4 equals 4 times b over 4. 4 cancels. So b equals 5. Now I've gotten my first variable. I will move ahead to go and get my second variable. Having gotten b to the 5, I will put it in any of the variables, in any of the equations. Like okay, put b equals 5 in equation 1. In equation 1, what does equation 1 say? Okay, equation 1 says 30 equals a plus 2a. So now 30 equals a plus 2 into bracket 5. So 30 equals a plus 2 times 5 will give me 10. This is a straight line equation, so we collect like terms. We collect like terms. We collect like terms. So this will come out maybe to have 30 minus 10 equals a. So therefore, a equals 5. Now we have gotten our two variables. A is okay, and b is also 5. Don't forget that when we're doing direct variation, the moment you get your k, you will go and get the relationship connecting. Don't forget that we were coming from the the relationship c equals a plus by. So now that we have our a and b, we substitute it. C equals 20 plus 5y. And this is the relationship connecting a and b. This is the relationship connecting a and b. This is the relationship connecting c and y. Sorry, we're coming from not from there. Okay. Sorry. We should have. Let me clean this. Let me clean this. So we're coming from x equals a plus by. So when you substitute it, x equals 20 plus 5y. That is the relationship connecting x and y. And that answers that. So we'll move on to the second aspect. Having gotten the relationship, the second aspect that says find x when y is 3. So from this relationship that we know, 20 plus 5y. Number B says find x when y is 3. That means anywhere I see y, I'll put 3 there, 5 into bracket 3. So x equals 20 plus 5 times 3 will give us 15. 5 times 3 will give us 15. Okay, so when you add that together, what do you have? You have x equals 35. So that is partial variation in simple terms. That's partial variation in simple terms. It's not a very difficult, it's not difficult at all. So that is it. That's it. In subsequent video, I'll also make another one where we'll see another example. It's a bye bye for now.